Every single person alive on this planet today had dark-skinned ancestors. Every single one. Not brown, not tan, just dark, deep and dark. Yours too, no matter what you look like right now. So somewhere in your family line, going back tens of thousands of years, the color of human skin changed. And the reason it changed is not what most people guess. Let's go back roughly 100,000 years to the plains and forests of Africa. This is home base for every human who has ever lived. The sun here is strong, straight overhead, all day, all year, month after month, with barely a break. Human skin at this point is packed with a pigment called melanin. Melanin is basically the body's built-in sunscreen. It soaks up ultraviolet light before that light can shred the DNA sitting inside skin cells. Without enough melanin, in a place with sun this strong, skin damage builds up fast, and so does the risk of skin cancer over a lifetime. But melanin is protecting something else too, something people rarely mention. It's guarding a vitamin called folate. Folate is critical for healthy pregnancies, especially for the early development of a baby's nervous system, the part of the body that becomes the brain and spinal cord. Strong sunlight can break folate down in the blood if skin isn't shielded properly. So in a sun-soaked climate, dark skin isn't just about avoiding burns. It's about protecting the next generation before it's even born. For the first long stretch of our species' existence, dark skin was doing double duty, guarding parents from cancer risk and guarding future children at the same time, and it was working exactly as needed. Now here's where the story moves. Starting somewhere between 70 and 100,000 years ago, small groups of humans began walking out of Africa. Not because life got worse necessarily, but because humans are wanderers by nature, and new land was there to be walked into, generation after generation, along coastlines and river valleys. They crossed into the Middle East, then pushed further, into Europe and Asia, into places with a completely different relationship with the sun than the one their bodies were built for. Higher latitudes mean weaker sunlight, especially through long winters. Days get shorter, the angle of the sun drops lower in the sky. The kind of ultraviolet light called UVB, the exact kind skin needs to make vitamin D, becomes scarce for months at a time, sometimes close to non-existent through a whole winter season. And vitamin D is not optional. It builds strong bones, it supports the immune system, it matters for a working brain and a working body overall. A person who can't make enough of it runs into real trouble, including a bone-softening condition called rickets, which can bend and weaken bones during childhood, and problems with pelvic bone structure that can make childbirth more dangerous for mothers. So think about the situation these early migrants walked into. Skin built for equatorial sun, now trying to survive on weak northern light for half the year. Dark skin, so effective at blocking UV in Africa, was now blocking too much of the very light the body needed to function. This created a new kind of pressure, one working in the opposite direction from before. Instead of blocking sunlight, bodies now needed a way to let more of it in. This is where natural selection stepped in, slowly, generation after generation, over spans of time that are hard to picture in a single human lifetime. People with skin that let in a bit more UVB made a bit more vitamin D, they had healthier bones and stronger immune systems. Their children survived more often into adulthood. Over thousands of years, with thousands of small advantages stacking on top of each other, populations in low sunlight regions gradually grew lighter. This wasn't a plan, nobody decided it. It was simple biology, repeated across countless lifetimes, favoring whichever skin tone kept people alive and reproducing in that particular patch of the planet. Here's the part that surprises most people, the twist worth knowing. Light skin did not appear just once. It evolved more than one time in different places, through different genetic changes. Genes with names like SLC24A5 and SLC45A2 show up strongly in European populations, while different variants, including changes near a gene called OCA2, show up in East Asian populations. Europeans and East Asians did not get pale skin from the same single mutation passed down one shared family tree. They arrived at similar-looking results through separate genetic paths, at different points in time. It's convergent evolution, the same outcome reached by more than one biological route, and it shows how strong this pressure from sunlight really was, strong enough to push different populations toward the same solution independently. And the timing is stranger than most people expect. For a long time, the assumption was that pale skin showed up quickly after humans left Africa and headed north, almost as soon as they arrived in cooler places. Ancient DNA has pushed back on that assumption hard. Genetic material pulled from skeletons found in Europe, some around 10,000 years old, shows people who still carried dark skin pigmentation long after their ancestors had already settled in cooler climates for thousands of years. One well-studied skeleton from Britain, often nicknamed Cheddar Man, is roughly 10,000 years old and carried gene variants linked to dark skin, alongside gene variants linked to blue eyes, an unexpected combination by modern standards. Light skin, as it turns out, kept spreading through European populations well after the last ice age ended, arriving in strong, widespread form only a few thousand years ago, closer to the rise of farming than most people would guess. That timing connects to something else worth mentioning: diet. Before farming took hold, many communities living in northern regions survived heavily on fish and on meat from wild game, foods that happen to be naturally rich in vitamin D. That dietary source may have taken pressure off skin needing to produce as much of it on its own. Once farming spread and diets shifted toward grains and cereal crops, that dietary backup for vitamin D shrank considerably. Skin had to pick up more of the workload through sunlight alone. Some researchers connect that dietary shift to the later surge of lighter skin genes spreading across parts of Europe. This particular piece is still debated among scientists, with ongoing research and real disagreement over exactly how much diet, sunlight exposure, and other factors each contributed, and the full timeline keeps getting refined as more ancient DNA gets studied and published. There's also a fascinating exception that proves how much diet matters in this whole picture. Arctic populations, including Inuit communities living at extremely high, low sunlight latitudes, kept notably darker skin than you'd expect for how little sun their region gets. The likely explanation ties right back to food. A traditional diet built around fish and marine mammals supplied plenty of vitamin D directly, so the usual pressure toward lighter skin never applied the same way it did to farming communities further south. It's a strong reminder that skin color was never only about how much sun hit a location. Diet, latitude, and biology were always working together on the same problem. There's a smaller, faster version of this same process happening in your own skin right now, and it might make the whole idea click. When skin gets more sun exposure over a few days, it responds by producing more melanin on the spot, which is the actual biological process behind a suntan. That's a short-term, reversible echo of the exact same system that shaped skin color over tens of thousands of years. Your body already knows how to dial melanin up or down depending on sunlight. Evolution simply worked out, over an enormous span of time, which baseline setting made the most sense for a given place on the map, generation after generation, instead of adjusting week to week the way a suntan does. Indigenous populations in places like South Asia and Australia add another layer worth noting. Despite being descended from groups that migrated out of Africa along similar general routes as Europeans, many of these populations kept, or in some cases re-evolved, notably dark skin, because the regions they settled in stayed close to the equator with strong year-round sun. The rule holds steady across every one of these cases. Wherever sunlight stayed intense, skin stayed dark, protecting cells and folate the same way it always had. Wherever sunlight grew weak and seasonal, skin lightened over time to let in enough UVB for the body to keep making vitamin D. Geography set the terms, and biology answered the same question over and over, in whatever way a given environment demanded. This tug-of-war between sun protection and vitamin D production hasn't stopped. It shows up today in sunscreen bottles, in vitamin D supplements sold at pharmacies, in doctors recommending sun exposure or blood tests depending on skin tone and where a patient lives. The same basic trade-off that shaped human skin color across tens of thousands of years is still playing out in daily life, just at a much smaller and slower scale than it once did. Meanwhile, in equatorial regions, the pressure never let up. The sun stayed strong. Melanin stayed valuable, protecting both skin and folate the same way it had for tens of thousands of years. Populations that kept the darker skin that had worked well since the beginning, because there was never a survival reason for that trait to change. So the whole picture is not one simple story of skin going from dark to light in a straight line. It's countless local stories layered on top of each other, each shaped by how much sun a place gets, how strong that sun really is, and what food was available on the table across the seasons. Skin color turns out to be one of the clearest examples in the entire human body of evolution, responding directly to environment, adjusting a trait almost like a dial, based on how much ultraviolet light a population actually needs to block, or let in, to stay alive and keep having healthy children generation after generation. The next time you notice the range of skin tones walking down any street in any city, in any country on Earth, you're looking at tens of thousands of years of bodies, solving the exact same problem using different amounts of local sunlight and different local diets, all branching outward from one shared starting point, all connected back to the same dark-skinned ancestors, standing somewhere in Africa around 100,000 years ago, under one very strong sun.